Hello again. Today I'm going to talk about displacement as promised. Displacement is a different way of measuring a change in position. Displacement is independent of path, so it doesn't matter how you got from A to B, you only need to know where A is and where B is. These are the starting and ending points. Displacement is the length of the shortest path between the starting point and the end point. That path will be a straight line like this. This is the path as the crow flies. It doesn't matter if you took a path that looks like this or crosses over itself. The displacement is always the same. It's this shortest distance, right here. Sometimes displacement is amusing. Have you ever watched the Indy 500? In this famous race, the world's fastest cars compete to race around a track 200 times, covering 500 miles of distance. But can you imagine the displacement of these race cars? It's zero. The cars start and end at the same position. It's a bit of a shame to do all that racing and end up with zero displacement. Calculating displacement is even easier than calculating distance. If our T-Rex moves from position 2 to position 5 and back to position 4 again, if we're calculating displacement, we don't even have to worry about the time he spends at position 5, since we only need to know his initial point, 2, and his final point, 4, and calculate the length of the shortest path between them. To calculate the length of this path, we take his final point, 4, and subtract from it his initial point, 2, and we get a displacement of 2 units. As we will see, calculating displacement on a coordinate grid is much easier than calculating distance. Let's say our T-Rex starts off at the origin. Here he is, looking fine. Let's say that he moves over here, gets to the corner of our grid. Now he's at this point 4, 3. Then he moves over here, maybe here, and then he winds up at this point called 0, 2. You don't have to worry about all the crazy path that he took. You only need to think about his initial point and his final point. Initial point is 0, 0. Final point, 0, 2. The x-coordinate is the same, so we only need to worry about his y-coordinates. It appears that he moves from 0 to 2, so 2 minus 0 equals 2. Let's try another example without a crazy path. Our T-Rex starts out at this point. He's at 0, 2. Then our T-Rex takes a stroll down the grid to the point 0, -1. Let's find out his displacement. Looks like our x-coordinates stayed the same, so we don't have to worry about those. Y-coordinate, however, changed. His final y-coordinate is -1 minus initial y-coordinate 2 is -3. He traveled -3 units. That seems a little bit silly. How can a T-Rex travel -3 units? In this case, the negative sign simply means that the T-Rex traveled in the negative direction along the y-axis, like this. This is a major difference between distance and displacement. Distance is a scalar, which means that it only has a number or a magnitude. This is why you don't have to worry about the negative sign if you're dealing with distance. However, when you talk about displacement, you have to describe both the magnitude and the direction of the displacement. The direction in this case is down, which is indicated by the negative sign. A quantity that has both magnitude and direction is called a vector. Therefore, displacement is a vector. In summary, distance is the measure of the length of a path traveled by an object. In this case, unfortunately, you'd have to measure the whole darn path. Displacement, on the other hand, is just the measure of the shortest path between the starting point and the ending point. This is much simpler. Distance is a scalar, so it's just a number, like 12, and a unit, like meters. Displacement, on the other hand, is a vector, so it's a number with a unit, like 12 meters, and a direction, like up. To calculate the length of any straight line path, the shortest path between any 2 points, this is important for distance and displacement, just subtract the final position minus the initial position. Thank you for listening.